Did you see Divergent this
It
weekend?
was really good. I loved it.
Oh, speaking of movies, I really want to learn about the mean value theorem.
Oh, what about the Rolls theorem?
That too! Oh my gosh, we need to figure this out.
Well, you're in luck because Avalie and I can teach you how. Let's go. First, let's look at the mean value theorem.
The mean value theorem says that if f of x is both continuous on the closed interval a to b and differentiable on the open interval a to b, then there exists at least one point c that in the closed interval a to b, the derivative of c equals f of b minus f of a over b minus a. This diagram kind of explains that concept that I just explained. The example we will do is f of x equals 1 plus the cube root of x minus 1 on the closed interval 2 to 9. The directions are use the mean value theorem to find all points c so that f of c equals m. The first step is to realize that the derivative of c will equal the slope of the graph, which will be f of 9 minus f of 2 over 9 minus 2, because the equation is both continuous and differentiable. The second step is to find the derivative of f of x. The derivative is 1 over 3 times the cubic root of x minus 1 squared. The third step is to compute the slope. F of 9 minus f of 2 over 9 minus 2 simplifies to 1/7. The fourth step says that according to the mean value theorem, there is one point c whose derivative equals the value we just found, 1/7. We find through lots of algebra that our answer is 1 plus or minus the square root of 7/3 cubed. But because it has to be on the interval 2 to 9, only 1 plus the square root of 7/3 cubed will work. The last step is just to verify your answer, and after verifying, we found that it is correct, and that is the mean value theorem.
Oh, wait. Oh, I get it now.
But what about Rolls theorem?
Now we are going to learn Rolls theorem.
Okay, so here's Rolle's theorem. For Rolle's theorem, you need to let f be continuous on the closed interval from a to b and differentiable on a to b. If f at a equals f at b, then there exists a number c in the interval a to b, such that f prime of c equals 0. Now we're going to do an example. For the example, prove that the function f of x equals x squared minus 2x satisfies the conditions of Rolle's theorem on the interval 0 to 2. So step 1. If you take a look at the graph, you can see that the function is continuous and differentiable on the interval from 0 to 2 because there's no break, point, or vertical asymptote. And you can also see that the value of f at a equals the value at f at b. So f at 0 equals f at 2. Now for step 2. Now that we know that the conditions are true for the function and we can use Rolle's theorem, there exists a point on the interval whose slope is 0. Now we take the derivative of the function. F at x equals x squared minus 2x, so f prime of x equals 2x minus 2. Now for step 3. We set the derivative equal to 0. F at x equals 2x minus 2, so 0 equals 2x minus 2. Then add the 2 equals 2x, and then 1 equals x. So therefore, there is a point, x equals 1, whose tangent line is horizontal. And that is Rolle's theorem. I hope you enjoyed learning it.
So that's the mean value theorem and Rolle's theorem. Do you guys get it now?
Yeah!
Thanks, Zach.